Hey guys, this is Fraser from Thanks About Tutoring. Today we're going to be looking at this 7-mark trigonometry question. We just put the marks in. So the first part is going to be 2 marks, so that's not too bad. That's just like a quick little test, but the second one is going to be the rough one. That's going to be 5 marks. So it's looking at composite functions. And so we have to find the composite function, and then we have to solve that being equal to something. And this is a classic trig question where they'll ask you to solve something given a certain range. Because as we all know, trigonometric functions are periodic, so they repeat. So if you just move along a period, you'll get infinitely many solutions. So they always specify, they always specify the domain along which we're solving, which is over here. That's the second part. So the first part is looking at these functions. We have f of x equals root 3 sine x plus cos x, and g of x is just 2x. And wants us to find f with this little og of x. This just means f of g of x. So it basically means that we replace all the x's in f with the function gx. So we just go ahead and we go f of g of x equals root 3 sine, and because we have an x, we now replace that with a 2x. 2x plus cosine of, and again there's an x, 2x. Actually, I don't need to put the brackets. So that's the first part. That's why it's 2 marks. It's not too bad. But you just have to make sure you get the order right. So it's f of g. It's not g of f, because if it was g of f, then we would replace all the x's in g with the function fx. So it's f of g. Okay, so that's the first part done. 2 marks, easy. Now the second part is a little more difficult. So we want to solve this f of g of x being equal to 2 cos 2x, where x is in that domain. So let's just go ahead and substitute what we found for f of g. I'm going to use this yellow color. So root 3, oh, that has a terrible 3. Root 3 sine 2x plus cos 2x is equal to 2 cos 2x. Now, quick hint. Because we have sines and cosines, and there's no squared, because if they were squared, we could write them in terms of the other one, right, with the identity. However, we don't have that. We just have a bunch of sines and cosines, and usually what's going to happen when we have sines and cosines is we're going to get tan, because we're going to get to a stage where we can divide by cosine, and then we'll get that we'll get some tan, hopefully. But that's just that's my general feeling here. So first things first, we have a cosine 2x on both sides. We can get rid of that. So that means we have that root 3 sine 2x is equal to cos 2x. And right off the bat, there we have it. We now have a sine on one side and a cosine on the other. So if we divide by cosine on both sides, what we're going to get is tan 2x, right? Because, quick reminder, let me write this down. It's in your formula booklet that tan x equals sine x divided by cosine x. And if we replace all the x's with 2x, this is still true. 2x, 2x. As long as you replace all of them. 2x. Okay? So that's just a little, let me just put that in a little box. That's just a reminder. The only thing you have to be careful of when you divide by cosine is you have to make sure that cosine being equal to 0 is not a solution. Because if it is equal to 0, and that is a solution, then we're dividing by a solution, we're losing a solution. But I think if we just check, I don't think that's ever the case here, because if cosine is 0, cosine x is 0, this means that sine x plus minus 1. So sine x is never going to be equal to cosine x when cosine is 0. So we're safe. That's just a quick check in general. If you ever divide by a variable, make sure it can't be equal to 0. So let's divide by cosine. So root 3 sine 2x over cosine x, we know that's tan 2x is equal to 1. That means that tan 2x is equal to 1 over root 3. And now this is something we can solve because we have trigonometric function being equal to a constant. Now this is a nice value. We just have to know our trig values. This means that 2x is equal to pi on 6. You can either remember the tan, or you can actually do it with the sine and cosine, right? So you know that you know that sine is at some point, it's going to be something to do with root 3, right? Or cosine is something to do with root 3. So you could try and figure it out that way. But to be honest, it might just be easier just to remember it like this. So 2x equals pi on 6. But remember, we have to be within this range, right? 0 to pi. And so you might think, well, if we add, because another quick thing, I'm kind of jumping around here, tan has a period of pi. So that means if I do a little drawing here, and tan looks something like this. It's a terrible drawing, but it's like this. The point is that this, like the distance between this and this, is pi. So they like repeats after pi. So that means if we add pi again, we're going to get the same value. You might say, well, that might be outside the range, but I don't think so, because we have 2x is equal to this. And so we're going to be dividing by 2, and you might say, well, why don't we divide by 2 and then add pi? Because we can't do that. Because we're saying that when 2x increases by pi, then we're going to get a new solution. If we're just increasing x, I think we might have to add pi on 2, but that's a bit tricky because it's not so obvious. So I think the best way to do this is, my recommendation is, once you have what the argument of the inside of the trig function is equal to, like pi on 6, pi on 3, whatever, add pi as many times as you want, or add 2 pi in the case of sine and cosine, and then solve. Don't rearrange it for x and then add pi, because that's not going to work. So if we add pi, we're going to get 7 pi on 6. If we add again, that's going to be 13 pi on 6. It's always good to add a couple more solutions. And because it can't be less than 0, that means these are the only ones that we should be looking at. And then divided by 2, we get pi on 12, 7 pi on 12, 13 pi on 12. Now I just added this 13 pi on 6, or this 13 pi on 12, just to show you that it's always good to just have a check. Okay, so this one is actually outside, because this is greater than pi, right? Because it's 13 over 12 is greater than 1. So that one is actually not going to be a solution, but these two will definitely be a solution. And so I think that these should be the final solutions. And that's 5 marks. So hopefully that was clear. These questions are pretty difficult. They were one of the hardest ones for me, and I think a lot of people have difficulty with imagining or maybe getting the initial solution is good, but then finding the other ones is always tricky. So yeah, I really recommend practicing these. I'll be making probably more of these ones as well in the future, maybe some harder ones. This one wasn't too bad, but it was, it's still difficult. But yeah, hopefully this was helpful. If you guys feel like you need a bit more help maybe to prepare for your exams, get ready for your maths exams. IB exams are coming up and not super long. Then feel free to head over to Thinks My Tutor, and you can grab a tutor there. When we do a couple of intensive months to get prepared for your exams, maybe you're in IB year 1 and you want to, get prepared early so you don't leave it to the last minute. But yeah, if you feel like you need a bit more help with tutoring, with maths, or other subjects even, feel free to head over to Thinks My Tutoring. The link for the website for international and for the Dutch and the international ones are down in the comments, in the description. So yeah, I'll be making more of these videos, and see you guys later.